Once again, good morning and welcome to our Mathematics 9 class. Now we're down to the last 7 lessons. And our first lesson for this quarter is about the 6 trigonometric functions. In this quarter, we'll be talking about trigonometry. For some, they call it trigonometry. Now, let's start by reciting today's memory verse, and it's found in Ecclesiastes 10 verse 2. It says, "A wise man's heart leads him in the sight in the right way, but the heart of a foolish person leads him in the wrong way." Our keyword is right. Why do we say right? In geometry or in trigonometry, we are dealing with right angles. And you'll see that in our next few slides. For your VCA boosters today, it's about a love triangle with God. Do you know that the secret of having a healthy relationship with family, friends, and special people? It is being in a love triangle. It's a love triangle with God. Now, what do you think will happen to a relationship if God is not at the apex? It means here on top, the apex. Our quote for today says, "Form a love triangle with God at the apex. Closer you move towards God, nearer you get to each other." At the end of today's lesson, you'll be able to illustrate the 6 trigonometric ratios, namely sine, cosine, tangent, secant, cosecant, and the last is the cotangent. Now, I will no longer deal with the venture with me, but let me share with you the definition of trigonometry. Trigonometry is a branch of mathematics that uses the relationships between sides and angles of triangles. In many real-life applications, it is used in physics and also in advanced mathematics. So if you'll go towards engineering courses, you'll have more on trigonometry. Let me introduce you to Heron. Now, who is Heron? Heron is a mathematician who introduced the tangent function in all of his studies in polygons. The Heron's formula, the formula we use in solving triangles with no altitude given, is attributed to Heron. Now, let me first orient you with the basic parts of the right triangle. You will see here in a right triangle, for example, if this is the given angle theta, this one is called theta. It's a Greek letter. It's the sibling of alpha and beta. So theta, this one, the opposite side of the angle theta is called the opposite side. Again, the opposite side is called opposite. The side na tapad, it's called adjacent. And the slant part, the opposite of the right angle, is called the hypotenuse. Now, there are 6 trigonometric ratios in a right triangle. We call it sine. If you have your calculators, its abbreviation is SIN, sine. We have cosine, COS. We have tangent, TAN. We also have cosecant, CSC, secant, sec, and cotangent, COT. Now, how do we solve for these trigonometric ratios? Remember, in this right triangle, we have the opposite, the adjacent, and the hypotenuse. You can disregard the A, B, and C. Just focus on the opposite, adjacent, and hypotenuse. Now, this is the formula, but let me give you right away my technique. It's SOHCAHTOA. SOHCAHTOA means saw. Sine theta equals opposite over hypotenuse. That is for saw. Next. The next one, ka. Ka means cosine equals adjacent over hypotenuse. The next one, toa. Toa means tangent equals opposite over adjacent. That's why toa, T-O-A. Next, cho. That's cosecant equals hypotenuse over opposite. Sha, secant equals hypotenuse over adjacent. Then cow means adjacent over opposite. So again, that's going to be sokatoa, cho shakao, cho shakao. If you notice, sine and cosecant are inverses. It's opposite of hypotenuse, then hypotenuse over opposite. So you just interchange them. For cosine, it's the inverse of secant. And tangent is the inverse of cotangent. If you'll see here, wait first. There. Sine and cosecant are inverses. Cosine and secant are inverses. Tangent and cotangent are also inverses. Now, let's start. First is, we determine the length of the hypotenuse of the right triangle below. Then, find the values of the 6 trigonometric functions of the angle. Let us start now. Now, if you see, this one is missing. So we need to solve for our hypotenuse. Remember that. Oh, wait for a while. Give me a pause first. Thank you. Now, if you see, this side is missing. So we will now start solving for this one. Based on theta, our opposite is 9, while our adjacent is 12. We are looking for the hypotenuse. So, opposite. That's going to be, remember the Pythagorean theorem? The hypotenuse squared is equal to the sum of the squares of two sides. So we have 12 squared plus 9 squared. It's going to be 144 plus 81. So our H is equal to 200. H squared is equal to 225. We square root both sides, so H is equal to 15. So our H now is 15. I suggest that you write it here on the side. O is 9, A is 12, and H is 15. Then we start finding the values of the 6 trigonometric ratios. We have sine, so remember, 9 over 15. Or you can reduce that to 3 over 5. Next, cosine, ka, so ka, toa, tangent is toa. Remember that, so toa. So our cosine is 12 over 15. Reduce it, that's 4 over 5. Next, tangent, 9 over 12, that's toa. Reduce it, divide both by 3. We have 3/4. The next one, cho, sha, cow. Cosecant, sha, secant, cow. Cotangent. Why did I place it beside? Because I'll just switch them. Sine is 3/5. Cosecant is 5/3. Cosine is 4 over 5. Secant is 5 over 4. Tangent is 3/4. Cotangent is 4 over 3. Any questions? Or give me a thumbs up if you have understood how to do it. Yes, AP, you raised your hand.
Ma'am, what happened to 20 h squared? Kanang 22, kanang 225.
One,
How did it become? How did it become
15.
15?
Because remember, AP, that's h squared equals 225. But we only need to get the value of h. So to get rid of the squared, we need to find the square root of both sides. So square root of h squared is h. Square root of 225 is 15.
Okay, thank you.
Other questions? No other questions? Then we'll go to the next one. Let me first clear this. Let's go to exercise number 2. Here. Okay. Using your chat boxes, help me answer. What is the value of, remember, we need to have it with reference to angle A. So if we say with reference to angle A, you look at angle A. What is the length of the opposite side? In your chat box. What's the length of the opposite side of A? 8, very good. What's the length of the adjacent side of A? Adjacent, 15, very good. How about the hypotenuse? What's the length of the hypotenuse? 17, very good. Now let's start with sine. Okay, in your chat boxes, you tell me, what's the value of the sine? What's the value of our sine? So, right? Opposite over hypotenuse. Okay, very good. Opposite, 8 over hypotenuse. So, 8 over 17. So, our cosecant is 17 over 8. Next, cosine. What's the value of our cosine? Not theta, cosine A. Very good. That's A over H. So 15 over 17. Next, how about of tangent A? Tangent A. So, toa. Okay, toa. Very good. That's 8 over 15. So the second A is 17 over 15. Cotangent A is 15 over 8. Very good. So I think most of you will get perfect scores in our quiz today. Now let's go to the next one. Ready? This time, in the next exercise, we will look at angle B. Okay, let's look at angle B. What is the length of the opposite side of angle B? In the chat box. What's the length of the opposite side of angle B? Very good. It's 15. How about the adjacent side? What's the length of the adjacent side of B? 8. Okay. Tawag na mo ni ang B, diba? So, opposite, 15. Adjacent, tapat, 8. How about of the hypotenuse? What's the length of the hypotenuse? Very good. It's 17. Let's start. What's the measure of sine B? In the chat box, sine B. That is so opposite over hypotenuse. So 15 over 17. Very good. How about of cosine B? Cosine B. Cosine. In the chat box. Ka, right? So, ka. So, that's 8 over 17. Very good. How about of tangent B? Tangent B is TOA. TOA. TOA is 15 over 8. Very good. Then, for cosecant, secant, and cotangent, these are inverses. So, 17 over 15. 17 over 8. And 8 over 15. You see, it's easy. Any questions? Before I go to the next example, we have 2 examples left. No questions? No, I need to ask questions because I'm not using my PowerPoint. I'm using the Zoom annotation. So once I'll erase this, everything will be erased. Now let's go to this one. Exercise number 3. Oh, I still have 3 more up to exercise number 5. Now in exercise number 3, the problem says, let alpha be an acute angle in a right triangle. So let's draw. And alpha is the acute angle. Given that sine is 9 over 41. Remember how do we find for sine? So, right? So the opposite of theta measures 9, while the hypotenuse of theta measures 41. What's missing? It's the adjacent. We need to find the other 5 trigonometric functions. So before we can solve for the other 5, we need to solve first for the adjacent side. Remember, the square of the hypotenuse is equal to the sum of the squares of both sides. So we have 41 squared equals a squared plus 9 squared. 41 squared is 1,681 plus a squared plus 81. We transfer 81 to the other side. Becomes minus 81. We are left with 1,600 equals a squared. But we need to find the value of a. So we'll do the square root of both sides. Square root of 1,600 is 40. Square root of a squared is a. So our a is equal to 40. Very good. Now let me write here. The opposite is 9. The adjacent is 40. The hypotenuse is 41. Sine theta is given, 9 over 41. Now in the chat box, can you help me? What's the value of cosine theta? What's the value of cosine theta? That's ka, right? So ka. So 40 over 41. Thank you, Tatiana. How about for the tangent? Tangent theta. What's the value? That's towa. Towa. That's 9 over 40. Very good, Janine. Next, since we have the sine, we only have the inverse for cosecant. So that's 9 over 41. 41 over 9, 41 over 40, and 40 over 9. That's it. Any questions? Or give me a thumbs up if you're cleared with that. Thank you. Now let's go to the next one. Let me see if, wait first. It's just the same. Okay, here. Let's go to the last example. I'll just do example number 5 because example number 4 is the same with example number 3. Now, QR is given to, QP is given. We're looking for RP. Again, the first technique is you need to complete the measures of the sides of the triangle. So let us have RP. Let's start. Remember, this is RP. So we have QP squared. The hypotenuse is equal to RP squared plus QR squared. So we have 5 squared equals RP squared plus, what's QR? 2 squared. 25 equals RP squared plus 4 to the other side. So RP squared is equal to 25 minus 4, which is 21. Square root both sides. So RP is equal to square root of 21. This one, square root of 21. Now, we need to determine all for Q. Now, in the chat box, can you help me? What is the opposite side of angle Q? What's the opposite side of angle Q? What's the opposite side of angle Q? RP, that's square root of 21. What's the adjacent side? What's the adjacent side of, wait first, I could not X. Wait for a while. What's the adjacent side? Very good, it's 2. How about the hypotenuse? What's the length of the hypotenuse? 5, very good. Now we're looking for cosecant Q. Okay, so katowa, cosecant is in cho. What's the measure of, what's the value of cosecant Q? In the chat box. What's the value of cosecant Q? Our hypotenuse is 5. Our opposite is square root of 21. But remember, in our previous topic on radicals, we could not have our radical denominator, so we need to rationalize that. You need to multiply it by your radical denominator. Square root over 21 over square root of 21. So the answer will be 5 square root of 21 over, cancel the square root, over 21. That's the answer for cosecant Q. How about for secant Q? Sha. Okay, there. What's the value for secant Q? in the chat box. That's very easy. For secant cube, what's our hypotenuse? 5/2. Okay, that's great. Then the last one, we're looking for cotangent cube. Cotangent cube. Cow. What's the value? That's 2/√21. It's a radical, so we rationalize it. We multiply the numerator and denominator by square root of 21. So we'll get 2/21 This ends our session for today. Do you have any questions? Feel free to raise your hand. No other questions? Let me stop the recording first.